it's time to finish the implementation of our calculator. First, let's make sure that our code still builds correctly. Yeah, we can see that everything compiles just fine, but we always get this annoying warning about an unused result that must be used. And it's on the line where we read from the standard input. So what does that mean? If we look at the readLine function, we can see that its return type is actually a result. And this result just wraps some number. So a result is in the core of the error handling in Rust. A result can be in one of two states, a success or an error. We will explore this in much more detail in the next section of the course, but for now, we should remember that there is one method on the result, which is called unwrap. If we call unwrap, it will make sure that if the result was an error, it will terminate our program. If the result was successful, it will yield the contents of the result, in this case, the number that the readLine function returns. So, to repeat, the unwrap will terminate the program if the readLine returns an error. In this case, it might return an error if it, for some reason, fails to read from the standard input. So, our program can't continue from that anyway, so we would want it to terminate. Now that we are able to read the user's input from the standard in, and we also have a function that calculates the Mars weight, like what's left to do is just pass the user's input to that function and print the result to the screen. Let's start by asking the user to enter their weight. So on the top here, we can add a print line, and where we will ask the user to enter their weight. And we can also specify that it is in kilos. So we ask the user to enter their weight. If we come back here, let's just run it to make sure. And yeah, we see that it asks us to enter our weight. We add some number and it keeps executing. So far, so good. Okay, we have the weight of the user in a string, but our calculate weight on Mars function expects a float. We have to parse our string into a floating point number. Okay. The first step to do that is actually remove all white space from the string. Because we type the value and press enter, it will always have a new line at the end. But also the user might press space a couple of times before they type their weight, and we want to trim all of that. So to do that, we can use the trim function on the string. So let's define a new variable called weight, and it will be equal to our input, but we also trim it. Okay, this will actually remove all white spaces from our weight. We can check this out if we just print our weight. And if we just run our program again, we add a bunch of spaces and then we type a number, and we see that we just log the number without the spaces. And the other log line where we just log the raw input, we still have all the spaces before our number. Okay, so far so good. But this is still a string. We can actually check the type when we are debugging if we change this macro to the debug macro. And if we use the debug macro, we don't need to specify the first string. Now, if we actually run our program, when it logs, it gives us a bit more detail about the variable. So it tells us exactly where the log line is, the name of the variable, and we can see that it is a string because it has quotes around it. Okay, how do we proceed to actually convert this string into a floating point number? Okay, so Rust has this cool function called parse. So we can just call parse on the string and it will parse it in the type that we want. So here we will see the power of the compiler once again. The parse function will parse the string into the type that we are expecting to assign to the variable. So the compiler will look at the type of our weight variable, and then it will call the correct parse function that will parse the string into this type. The problem right now is, though, that the compiler doesn't know what the type of the weight variable is. So it says that it cannot infer a type for the parameter. And it also tells us that we should give weight an explicit type. So let's do that. If we actually tell weight that we want it to be a float, if we try to build now, we see that it still doesn't work. So it tells us that our variable was expecting an F32, but it actually found a result. So once again, we see this result. The reason is that the parse function returns a result, as we can see here, because it might fail parsing. For example, when we're trying to parse into a float, if we have some letters in the middle of our number, that's an invalid number, and the parse function will fail. So if we just call the unwrap once again at the end of the parse, everything is happy now, because the unwrap will fail if the parse fails, or it will yield the parsed value and assign it to our weight function. So now, actually, the code compiles, we have no warnings, and everything is great. So finally, we have our weight. We can also just actually run it to see our debug macro. So type 1, 2, 3, and we see that it is a floating point number now. Okay, what is left is actually deleting these log lines and then just pass the weight to our function. Okay, let's see how that would work. If we run it now, it asks us about some weight. We type 100 kilos, let's say, and it tells us that the weight is 37.83, the same. So if we run it again, we type 50, and yeah, we get a different value. So finally, our Mars calculator actually works.